All right, guys, we're on page, sorry, what page are we on? We're on page 163 of your student journal, section 6.2, Exponential Growth and Decay. I'll let you know ahead of time that this section is it's simple, but it's technical in that it's simple mostly because if you can look, it's mostly just substitution. It's technical in that it's very heavily formula based. But yeah, I'll go through those and explain things as best I can and try and keep a balance between explaining too much so you don't get bored and explaining enough so that you understand what is going on in these formulas. So growth and decay are exactly what they sound like. Growth is when something is increasing. Decay is when it's decreasing. So essentially, exponential growth. So I explained last section that an exponential function is when you're multiplying or dividing. Here in the book, they still refer to it as strictly by multiplying. And so if you are growing, then you are multiplying by a number greater than 1. Sorry, where is that here? A number greater than 1. And then if you are decaying, then you are multiplying by a number less than 1. Or also, to me, I just categorize that as dividing. But again, I could see both ways to explain it, so it still makes sense. Exponential growth, a function in the form y equals a times 1 plus r to the t. A has to be greater than 1, has to be positive, and r also has to be greater than, a has to be greater than 0, and r also has to be greater than 0, it has to be positive, because if it was not positive, then you would be multiplying by less than 1. Final amount equals initial amount, rate of growth in decimal form. This is important. 1 represents 100%. This is just 100% in decimal form, and if it's growing, that means it's going up, right? It has to be more than 100%. So, for instance, as a review, you should practice converting decimals into percents and vice versa. So, 11%, for instance, might be 0.11. 1% is 0.01. 10% is 0.1. 20% is 0.2. 21% is 0.21. So as a reminder, if you start off at a percent and you just bump it over twice, and you have a placeholder if you need it. The placeholder is 0. There you go. Here, starting at the end, that's just 0.1. Starting at the end, that's just 0.2. Starting at the end, that is 0.21. Okay? So if I start off at 100% and I move the decimal twice, that is just the number 1 or 1.0, whatever you prefer. After you add it to 1, after you add the rate of growth to 1, that is your growth factor. So for instance, if I have like 1 plus 10% is 1.1. So 1.1, the rate of growth is 10%, but the growth factor is 1.1. Okay, moving on into decay. Really, this is all the same thing, except r has to be between 0 and 1. If it was negative, then you would be adding it, so it doesn't really make any sense. So you subtract it because it's decay. And everything else stays the same, really. The rate is a decimal, so don't forget how to convert percentages to decimals. And instead of a growth factor, since it's getting smaller or decreasing, then we can call it a decay factor. And sorry, I don't think I explained this time. That's the number of times it's happening. So let's say if you have days or hours or weeks or months or years, really, that's just your time. So the last thing is compound interest. Compound interest is the interest earned on the principal and on previously earned interest. So that's the compound interest is what they say is a big deal about your retirement or when you start saving money early, is that your money grows, and while it's growing, it also grows with the amount that it grew by. So a lot of growing essentially. Principal, P is principal, whatever, initial amount, initial just means start, so that's your starting point. R, annual interest rate, again in decimal form. Annual interest rate means interest rate over the whole year. T is time and number of years, and N is number of times interest is compounded per year. So for instance, if something's compounded daily, that's 365, right? And then if something is compounded monthly, that's 12 times, so that's 12. If it's weekly, that's 52 times, so n would be 52. So I will jot that down really quickly for n, because that's like very specific. Daily equals 365, weekly equals 52, monthly equals 12, annually equals, that just means each year, which means just 1. These will be important, so do copy those definitions down. Okay, so I went through the formulas, and like I said, it's going to be simple because we're just literally referring to these, the growth one, the decay one, or the compound interest one every time. Going to be very technical because you have to define, oh, what's the principal? Oh, I got to put that over here. Oh, what's the annual interest rate? Oh, I got to put that there, and so on and so forth. So as a reminder, let's see here, y equals a initial 1 plus r to the t. So this is the growth rate, and the whole thing is growth factor. So it's the rate in decimal form, initial, or starting amount. So I'm going to try and go through this kind of slowly. In 2005, there were 100 rabbits in Polygon Park. The population increased by 11% each year. I don't know what you jumped to, but I'll just say 100 rabbits. That is our starting point. So looking in here, sorry, that should say rate. God, that's hideous. Okay, so 100 rabbits. So 100 rabbits is not a rate, and it is not a unit of time. It is our starting amount. They say y equals 100 times 1 plus the rate is 11%. Convert that to a decimal by sliding that over twice to the t. Or if you want, since it's years, you can call it years. Oh, but it says population t years. Okay, after 2005. That's it. So that's it. We're done. That's our function. What will the population be in 2025? So how many years is that from 2005? That's 20 years, right? So we just replace the t with a 20. I actually have already done it here. 100 times 1 plus 0.11, or another way to write this is 100 times 1.11 to the t. These are the same thing. I wrote it out like this to show you completely. It says round to the nearest whole number, so that's 806. So after 20 years, or in 2025, there will be 806 rabbits. And again, you would copy what I wrote right here to show your work for part B. So you'd write y equals 100 times 1.11 to the 20th power to indicate 20 years. Determine whether the table represented exponential growth and exponential decay, or neither. So I actually realized that I didn't show you how you could get this. So on a calculator, you would just take each term and divide by the previous term. So I would take 30 and divide by 20. I would take 45 and divide it by 30. And really, you just got to see if you're getting the same thing. So let's start at the bottom and go upwards. 67.5. 67.5 divided by 45. 1.5. Okay, so 1.5. 45 divided by 30. 45 divided by 30. Oh, 1.5. 30 divided by 20. 1.5. So 1.5. 1.5. And this actually is a way of finding out, oh, that's the number you... So I was showing you division. But this is how you get the factor that you are multiplying by to go from the top down. So 20 times 1.5 gives you 30. 30 times 1.5 gives you 45. 45 times that gives you that, 67.5. Again, I will do the same thing. Oh, sorry. We're multiplying by a number greater than 1. 1.5 is greater than 1. So that's exponential growth. Exponential growth. Exponential growth. Because because the y value is being multiplied by a number greater than 1. Greater than 1. I'll do the same thing here. 2.5 divided by 10, 0.25. 10 divided by 40, 0.25. And 40 divided by 60 is going to be, I'll show you anyways, 0.25. So multiplying by, multiplying by, multiplying by. Exponential decay because the y value is being multiplied by a number less than 1. Less than 1. Okay, 2 divided by 12. 2 divided by 12. 0.166666. 12 divided by 22. Ah, here, you see, if it's not it has to be consistent. It has to be the same number. So now I could go back and say that, okay, well, it's not exponential growth or decay. And in fact, if you analyze it closely, 32 to 22 is subtract 10. 22 to 12 is subtract 10. 12 to 2 is subtract 10. So this is neither. This is a linear function subtracting by 10. Let's see here. 62.5 divided by 25. 62.5 divided by 25. 2.5. 25 divided by 10. 2.5. 10 divided by 4. 2.5. So each time we are multiplying by 2.5. If we're multiplying by a number greater than 1, I will let you read the other 3 explanations and decide whether this is exponential growth or decay. Read one of those. It will clue you in. Moving on. Determine whether each function represents exponential growth or exponential decay. Identify the percent rate of change. So this is still referring to these two functions, growth and decay. Don't forget, for growth, it is 1 plus something. For decay, it is 1 minus something. So if we're looking at this, let's go down. So if our starting point is 1, to get to 0.95, do you have to subtract or add? And the answer is you subtract. 1 minus 0.05. 1 minus 0.05 gives you, 1 minus 0.05 gives you 0.95. So really, so this is, if I had to subtract exponential decay, the rate of change is 5%. So if I change, if I look at this as a percent of change, turn this into a percent, that's 5%. Starting off at 1, how do I get 1.08? I have to add, how much I have to add by? 0.08. Right, so this is growth. Kind of obvious, should be obvious, greater than 1. Or greater than 100%, or 1. Exponential growth, the rate of change is 8%. 8%. This is 0.75, or 3/4. So before we can do it, we have to identify it as a percent. So 3/4. That's 0.75. So if I'm starting off at 1, which I always am, and to get to 75%, do I have to go up or down? So 100% to 75%, that's a decrease. How much is that a decrease by? It's a decrease by 25. So we have 1 minus 0.25. Exponential decay, rate of change is 25%. You're decreasing by 25%. Okay, and lastly, you'll notice that I'm working through all these. There's just a lot of variety in these problems. So hopefully these explanations, you'll go into your textbook and have more work to practice on. But there's very little here to work with, so I don't feel bad like explaining most of it to you guys. Write a function that represents the balance after 2 years. Okay, finally, we're going into this, this compound interest formula. So principal is starting amount, annual interest rate, time in years, number of times. So again, that's referring to the weekly, monthly, daily. 3,000 deposit that earns 6% annual interest. So, sorry, let me go back one more time to show you guys. Y equals principal, parentheses, 1 plus r over n, close parentheses, times, or to the n times t power. So I'll just copy that over here. Y equals principal, 1 plus r rate to the nt. So now we just have to identify our p, our r, our n, and our t. So $3,000 deposit, this is our p, 6% annual interest rate, this is our r, but we have to turn it into a decimal. So 0.06 is our r. Compounded quarterly, quarters, that means 4 times a year. Every quarter, so like January, February, March, that's a quarter. January, February, March, April, May, June, that's another quarter, so on and so forth. So quarterly means 4 times. So this is our n. So I'm going to say y is equal to, so you could write this right there, 3,000 times 1 plus 0.06, that's a 0 by the way, 0 divided by 4 to the 4t power. Notice the n shows up twice and it's the same number. And I will leave this here for you. Monthly means 12. This is our P. Our R is 0.072. And you guys practice writing it like this. So if you have any questions, ask your teacher or let me know. And we are finished with section 6.2 of your student journal.